In this video, we're going to do some extra examples on rational functions. So those are polynomials divided by polynomials. We want to make sure to include the intercepts, the asymptotes, and any holes that are present. Okay, so we're going to start with this function here. So f of x is 2x plus 5 over 3x minus 9. The first thing we always want to do when we're sketching anything is think about the domain. Okay, so the domain, we cannot have the denominator being 0. So actually, let's do this underneath. Okay, so we need 3x minus 9 to not be 0. So that means that we need 3x to not be equal to 9, which means that x should not be equal to 3. Okay, so the domain is x not equal to 3. Okay, so that's the first thing. And then we can do the intercepts. So let's do the Y-intercept. So that's we set x equals 0. Okay, so that y is going to be 2 times 0 plus 5 over 3 times 0, minus 9. So that's going to be negative 5 over 9. So we have a point at 0 and negative 5 over 9. Okay, now the x-intercept, here's where we set y equal to 0. So that means 0 is equal to 2x plus 5 over 3x minus 9. Now when you have a fraction equaling 0, this is true when the top is 0. Okay, now you want to make sure the bottom isn't 0 at that time as well. Okay, but we need the top to be 0, so if I solve for this, I'm going to get x is negative 5 over 2. Okay, so now we have another point at negative 5 over 2 and 0. Okay, let's just put those out. Okay, now, do we have any, let's do horizontal asymptote first. Okay, we're going to have a better way to find this, but here I know that the horizontal asymptote is y equals 2/3. Okay, so this is since the degree on the top equals the degree on the bottom. So when that happens, you just take the y equals the coefficients. Okay, so that's going to be y equals 2/3. Okay, now a vertical asymptote, those are points that are not in the domain. So the only place that we could have a vertical asymptote is at x equals 3. And it turns out that we do. So as we get close to 3, the y values are going to get really big or really small. Okay, so we're going to have a vertical asymptote at x equals 3, and we have no holes. So those are the things that we wanted to make sure we include in our graph. Okay, so I need to get to 2.5 and 3. So let's make it 1, 2, 3, negative 1, negative 2, etc. Okay, so at x equals 3, we have a vertical asymptote. At y equals 2/3, we have a horizontal asymptote. Okay, and then we have a point at negative 2.5 and 0. And we have a point at 0 and negative 5 over 9. So that's sort of around here, I think. This is negative 1. Okay, so this is maybe not looking very helpful. So there are things that we can think about. So first of all, we could plug in some extra points. Okay, so we might want something when x is bigger than 3. So maybe if we try x equals 4. Okay, so then y is going to be 8 plus 5, so 13, over 12 minus 9. is 3. Okay, so that's 4.33. Okay, so that gives us another point. So at 4, we're 1, 2, 3, 4. We're up here. Okay. Another thing we can do is, so remember you could cross a horizontal asymptote. Do we cross the horizontal asymptote? So that means we want to know, is there an x value where the y value is equal to 2/3? Okay, so this is 2x plus 5 over 3x minus 9. So we can multiply, we can actually cross multiply, I guess, if you want. So that's going to be 3x minus 9 is equal to 3 times 2x plus 5. So that's 6x minus 18 equals 6x plus 15. So if I subtract the 6x to move it to the left, we can see that it actually cancels out on both sides, and we get negative 18 equals 15. Okay, so this doesn't make sense. So that means that the answer to this is no. Okay, so there's no point where we cross the horizontal asymptote. And we know that this is a sort of like 1 over x reciprocal function. So I think we can say that the graph is going to look something like this and something like this. Okay, where we come down here. Okay, because we know that we can't cross the vertical asymptote, and now we know that we can't cross the horizontal asymptote, so there's not much else that we can do here. Okay, so as x gets really small, so as x goes to negative infinity, we have to approach the horizontal asymptote. So from here, it has to go like that. Okay, as we approach 3, we know we're going to go to plus or minus infinity because this is a vertical asymptote, but we can't go to that one because then we would cross, so we know it has to go down. Okay, and the same thing over here. Okay, so that's what our graph would look like. Okay, let's try another one. So again, start with the domain. Okay, so we cannot have x squared minus 4 equal to 0. Okay, so that's x plus 2 times x minus 2 cannot be 0. So that is 0 when x is plus or minus 2. So that means that x cannot be plus or minus 2. So that's our domain. Okay, if you wanted an interval notation, it would go negative infinity to negative 2, not include negative 2, and then negative 2 to 2, round brackets, so we don't include those values, and then 2 to infinity. Okay, so that's the domain. Now, after we do the domain, we can actually simplify the function. So I can pull out a 2 from the top, and I get 2 times x minus 2, and then the bottom we know factors as x minus 2 times x plus 2. And now I can see that these things cancel. So I get 2 over x plus 2. Now they cancel as long as x minus 2 is not equal to 0. So as long as x is not equal to 2. Okay, so everywhere that x is not 2, this function is actually equal to this function. So as long as we're not thinking about at x equals 2, we can use this function instead of the original. So it's easier to work with. Okay, so intercepts. Okay, so the Y-intercept can only have one intercept. Oops, I don't want that. So the Y-intercept, we just plug in x equals 0. So y is going to be 2 over 0 plus 2. So that's 2 over 2, or 1. So we get the point 0, 1. Okay, x-intercept, that's when y is 0. So it's going to be when x plus 2 over x plus 2 equals 0. A fraction is only equal to 0 when the top is 0. So that means 0 equals 2, which means that there's no x-intercept, because that doesn't make sense. So we don't have any x-intercepts. Vertical asymptotes, we have only one. Okay, and it's when x is equal to -2. Okay, now let's just write. So because that's left over, okay, that's when this part is 0. That's going to be a vertical asymptote because that problem is still left over. We did have the problem at x equals +2 as well, but we were able to cancel it out. And when that happens, it means that we actually have a hole when x equals 2. Okay, now if we want to find the y value of that hole, what you can do is actually plug in 2 into the spot where you're not supposed to plug in 2. So when we are close to 2, but not equal to 2, we can use this expression, okay? As long as it's not actually 2. For 1.99999, we can use this. If we're 2.00001, we can use this. Okay, you can be as close as you want to 2, and then it's going to follow this. So the values that this approaches is going to be what the y values are getting close to. Okay, so the y value is going to be 2 over 2 plus 2, which is 2 over 4, or 1/2. So we have a hole at the point 2 and 1/2. Okay, now we have a horizontal asymptote at y equals 0, and that's because the degree of the bottom is bigger than the degree of the top. Okay, so that's our horizontal asymptote. So we can start plotting these things. So there's a horizontal asymptote here, and we know we never cross it since there's no x-intercepts. Okay, we have a vertical asymptote at -2, 2. Okay, and at +2, okay, so here's 1 and 2. So at +2 and 1/2, we have a hole, we know that. And we know that we have the y-intercept is at 0, 1, so that's going to be here. Okay, so that's what we have so far. And again, we probably could guess what it looks like at this point, but if you want to do some extra points, you can. Extra points. So it might be nice to have something smaller than -2, so -3. So we can use the simplified version, so that's 2 over -3 plus 2. So that's going to be 2 over -1, so -2. Okay, so at -3, sorry, we're at -2. 1, 2, so it's going to be down here. Okay, maybe that's enough. So when we come here, we cannot cross the x-axis, so that means we have to approach the asymptote this way. Okay, and then we have to get to this hole, and then we're going to approach this horizontal asymptote we cannot cross. Okay, and same over here, as x gets small, we need to approach that asymptote, and as we get close to -2, we have to approach that asymptote. So that's what our graph would look like. Okay, so you have a hole here is at 2 and 1/2. We have a point at 0, 1. We have a point at -3, -2. And a vertical asymptote at x equals -2, and a horizontal asymptote at y equals 0. Okay, so that's a sketch of the graph. The further we get into calculus, the better these sketches will get, the more information that we'll have.